Hey, good morning. I think we'll go ahead and get started. I show a couple minutes after 11 now. Thank you for joining us this morning for our Solid Edge webinar, hosted by PROLIM in conjunction with Siemens. Kevin, if you can move to the next slide. So our agenda this morning will be just brief introductions. I am Rich Solte with PROLIM. I'm the Vice President of Sales here, and this morning we'll also have the pleasure of hearing Kevin Grayson from Siemens presenting for us on the Solid Edge product. I'm going to start out with just a quick overview of who PROLIM is and how we can help you as the Siemens partner of choice for your Solid Edge and PLM related needs. And then Kevin's going to jump into the presentation itself, which will take all in all about 45 minutes. I would ask that everyone mute their line during the presentation and hold your questions till the end, or if you'd like, you can also submit them through the chat line to me directly. And we will spend about 10 to 15 minutes on questions, and then we'll wrap up by noon. So just a quick overview of PROLIM. We have been in business for 11 years. We're headquartered in Metro Detroit and Farmington Hills. We also have an office in Dallas. We are a Siemens partner focusing primarily on PLM-related integration with Teamcenter as well as the Solid Edge product. And we focus mostly on IT and engineering-related services surrounded with PLM solutions that we provide to our customers. We support just about every type of industry you can think of, obviously heavy in the automotive, manufacturing, high-tech, and aerospace. And most of our services are done in a combination of onshore and offshore. So we have two offshore centers in India as well as a presence in Germany. So that is our global footprint for supporting our clients in different engagements when we help them. So with that, I'm going to turn it over to Kevin, and Kevin's going to start the presentation.
All right, thanks, Rich. Thanks, everybody, for joining us this morning. I wanted to pull up a slide before getting into the actual presentation and just talk a little bit about the Solid Edge portfolio of products. I think what most people think of when they hear Solid Edge is they think about its rich design capabilities. But what you may not know is that Solid Edge actually has a lot of built-in integrated applications for simulation to test your designs, manufacturing, if you want to simulate a manufacturing process. We also manage all the files with a built-in design management solution. And then for anything else that you may need on top of those applications, we have a wide variety of apps that you could add on to Solid Edge and integrate with the product. So I want to make sure everybody was aware of the Solid Edge portfolio of products before focusing in on the demonstration today. What we're going to do today is we're going to do a demonstration utilizing one of our customers' products. It's a company called Master Mover. I'm going to play a quick video. Just gives you some ideas as to what the Master Mover product line is. These guys basically create these equipment that moves heavy loads, and we're going to focus specifically on the product you see that's in the movie right now called the Smart Mover. It's giving you some information here within the video, but you'll notice also that many very wide-known customers around the world utilize this product. So Aston Martin, Ford Motor Company, and even Siemens utilizes this product in some of their different areas. And it's a great product. We're going to look at it specifically with one of the clamping mechanisms. You'll see this clamping mechanism in the video. Basically transfers the weight of the load onto the axle for traction, which makes it much easier to move the heavy equipment. So we're going to focus on that specifically in the demonstration today. The workflow we're going to go through is listed on your left. You'll see we're going to create some components. We're going to model some parts in 3D with part design. We'll create a 2D documentation or 2D drawing of that 3D model, show you how easy it is to do that. We'll also talk a little bit about data reuse, whether you have legacy 2D CAD files, or maybe you're using another 3D CAD system today, Solid Edge does a really good job of reusing data from other CAD systems. We'll show you some examples there. We'll get a little bit into the assembly design on putting parts together, how easy it is to do that, as well as document and create bills of materials. We'll also talk a little bit about the built-in simulation tool, where we may need to check for strength and see if a part's going to work properly as it was intended, and then kind of wrap it up in showing you the built-in design management application within Solid Edge. Before we get into the part design portion of the presentation, I wanted to give just a real quick history lesson on CAD and where Solid Edge is moving in terms of some of the applications that are built into Solid Edge and different modeling techniques. So on the left-hand side, you'll see we have what we call history-based modeling. This is modeling that was essentially created and started in the mid-1980s. It was enhanced and developed and put on a Windows platform in the mid-90s. Many of your CAD systems out there today are utilizing this approach to modeling parts in 3D, Solid Edge included. Solid Edge has history-based modeling tools. Most of your 3D CAD users out there today are utilizing this approach. Essentially, when you create models, you're creating 2D sketches, which are then creating features. Those features are basically built on top of each other, and when you're finished, all those features make up the entire part. There's a lot of good things about history-based modeling. It's dimension-driven or parametric. You can drive the model very easily. It's also feature-based. There are some downsides, though, to history-based modeling, which we'll talk about in a little bit more depth later. But you'll notice that a lot of times utilizing a history-based modeling approach, a lot of times you have to pre-plan your design and how you're going to model it within the CAD system before you actually get started. So sometimes there may not be much flexibility down the road if you need to make certain changes. Sometimes you're able to make the change easily, sometimes not. Many times CAD users utilizing this approach will find themselves having to remodel the part again from scratch if a particular change downstream can't be made very easily. On the other side of the spectrum, we have some tools out there on the market that are referred to as direct modelers. And direct modelers are more I guess it's more of a CAD paradigm where you have a little bit more direct interaction with the model itself. These types of applications allow you to pull on faces of the model directly or push on the faces to make changes. So editing those types of components is very, very easy. It's very flexible. Some of the downsides, though, to a direct modeling approach is, they're really not comprised of a feature-based model, and there's little automation that can be done within these types of modeling procedures. Also, the dimensioning, while there is some dimensioning and parametrics involved, they're very, very weak. A few years ago, Solid Edge decided that we wanted to combine the best of both worlds of history-based modeling and direct modeling. So we took the best of both worlds, added some innovative techniques there in the middle, and it comprised the tool set that's found inside of Solid Edge called synchronous technology. So with Solid Edge, you have a lot of flexibility on how you can model parts. You can use both history-based modeling approach as well as synchronous technology to create these parts very, very easily. So what we're going to do today is I'm going to show you, again, how within the demonstration we're taking the best of the history-based modeling, the best of the direct modeling approach. We'll also incorporate some of the innovative tools that Solid Edge developed to create synchronous technology and show you live in the demonstration how this particular CAD paradigm works. I'm going to pull up Solid Edge, and again we can see the master mover tool that we're going to start creating some components with. And you'll see here we've got the entire machine. We're going to go through a kind of a day in the life scenario of an engineer or designer who's been tasked to either make changes to this or maybe create some new components. What I've been tasked to do is to construct a brand new part from scratch that's going to connect our clamping mechanism up here in the front to the main body. What I may want to do initially is turn off some of the outer components. Maybe I just want to look at some of those internal components. The Solid Edge is very easy to show and hide components at will, and maybe I just want to see some of those internal components. This is what we call display configuration, and it allows us to create that very easily for what we want to look at. As I zoom into these components, give you a little bit better feel for where we're going with this, I need to connect, as I mentioned, the clamp mechanism that's kind of just floating out there in space right now, kind of connected with the hydraulic line to the main body. So in Solid Edge, I'm going to go through and show you this approach. In Solid Edge, you have the ability to use what we call a bottom-up design approach or a top-down design approach. Bottom-up meaning I go in a blank design area, model a part by itself, and then bring it into the assembly later. The top-down approach is a little bit more flexible in terms of I can model my new part relative to my existing components. So I can check for fit and function as I'm doing the design and make sure that I'm not going to detect any interferences, or as I'm completing the design, it's going to fit properly right out of the design process. What I can also do is reference the geometry of all these existing parts. So what I'm going to do is say I want to create a brand new component, and you'll notice I can snap to any location here or where I want the part to begin. You'll notice also I can specify which direction is X, Y, and Z very easily. Many companies today utilize a smart numbering approach to creating document numbers. Solid Edge does the same thing. We have a nice smart numbering generator system. So for example, if I know that instead of looking up in an Excel document what the next available document number might be for my company, what I can do is automate that process and have it generate the next item for me within the CAD tool. And from there, I can automatically create that within the creation of the new document. We'll call this, for example, the clamp arm. We will give it a nice description. Again, I can specify where I want to save my documents here. Again, we'll talk a little bit more about the built-in data management tools a little bit later, but we'll save it here within our working location. The other thing I want to draw your attention to as we're modeling this part is pay attention to how much actual 2D drawing that I actually do. You'll see how minimal it is in creating this part. The first thing I want to do is borrow some geometry off of some existing components. I know that my part's going to reside somewhere in this area, so I can grab the face of an existing part and very quickly just stretch it down and mount it to the part that's underneath it. And as I turn off my background components, you'll see exactly what it just created for me. Very, very quickly, without having to draw any type of 2D geometry, I've created this as the basis of my part. Now right here in the middle, I've got two little rectangular cutouts. I actually don't want those to be cutouts. I actually want to create a slot. And very quickly, I can just simply drag my mouse through that zone and eliminate that material. So it creates more of a clamping component versus the little cutouts. I also have a lot of direct interaction with the part as well. For example, if I want to lengthen this area out a little bit, I can do that just by typing in a value. Very quickly stretch the component out again without having to create any 2D geometry. As I turn on the background components again, as I mentioned, we need to mount it to our clamping mechanism out here in the front. So I may want to create some additional material. And again, I can reference what I have so far and very quickly either cut away or extend material up or maybe the area where it's going to clamp into the clamping mechanism. Now, as you look at what I have so far, obviously, I'm not completely finished with my design. I might need to create a slot or a cutout here in the middle of my clamping arm, some mounting holes here so that this component here can mount to that. And I'll go ahead and do that here in a few minutes. In the meantime, I just want to focus in on some of the other details of my design. For example, let's get rid of some of those sharp edges. We can go through and just tag some of these sharp edges very quickly, and eliminate those and put some rounds on. Notice I can also pick through the part model to get to edges that are maybe on the back side. We'll round those edges first, come in and maybe round with a smaller radius, the outer edges, and get this part looking a little bit more aesthetic. The other thing too is I don't have to create, as I mentioned, a bunch of 2D sketches to create features. I can very quickly make my model parametric. So notice that I can directly dimension the model itself. And what's nice about our dimensioning tools is how flexible they are. Notice with placing a dimension on this part, I can choose to extend material out to the right to add material that way, or maybe I want to split the difference and have it grow in both directions, or I can just have it go towards the inside. So I'm very flexible with how the part is modified. I have control over that as the user. We'll make that 45 millimeters exactly. So it's not just about pushing and pulling and randomly picking what that's going to be. I can very easily place precise dimensions on the model. We'll add a few more so that I can get my part exactly what I want it to be. So we'll add a few more dimensions. Maybe place a dimension here that extends out, and maybe we'll make that, let's say, 40 millimeters exactly. You'll see the part automatically updates there. Maybe we want to change the length of this slot to some other value. Right now it's at 31.3. Let's make that 34 even. Dimension the bore here. We'll call this out as a diameter versus a radius. We'll change that value. Actually, while I'm at that, let's actually put a tolerance on that. We can easily go from nominal dimensions and maybe instead put a tolerance value on that, maybe plus or minus some values. Get that. And then maybe we'll add one more dimension over here for that slot cutout that we created earlier. And maybe we'll make that some value, let's say 9 millimeters. So you can see how easy it is to throw dimensions right there on the model, make adjustments as necessary. Maybe the last dimension I'll place is maybe an overall height. Let's see how tall this is. And yeah, that's 150 is what we're looking for. So being able to parametrically create and modify the part at will without having to create 2D sketches is what separates synchronous technology from the history-based modeling approach, where typically you're spending more time drawing than you are working on your actual design. I'm going to turn off these dimensions for a second. Again, let's turn on those background components, and let's take a look at what we have so far. I'm almost done with the design. I just need to quickly maybe put that slotted cutout and those mounting holes in my part. Let's get some information from other components. Let's see how wide this is. It tells me it's just shy of 8 millimeters in width. So when I create a slot, I know exactly what the width needs to be. We have a specific slot feature, which we can create. Let's just specify where we want that to be. Again, this is only the second piece of 2D geometry I've created, and again, it's just a simple line. And from there, I can go through my slot feature and say, let's just blast a slot right through the part. And from that simple line, it creates a nice slot for me. We mentioned earlier, too, about the benefits of CAD being feature-based. And you can see over here on the left-hand side all the different features that comprise my component. So I have protrusions and rounds. I have that slot feature that I just created. And just like you might be used to if you are utilizing a history-based application, you can come in at any point and modify those features. Maybe instead of a flat edge to my slot, maybe instead I want to have a nice rounded edge. So I can go into that feature and make modifications to it very easily. Or if I wanted to change the width, for example, feature-based modeling allows you to make those changes very easily. We'll make that back to a flat end. Again, let's turn on my background components and just make sure that my part's fitting in there nice and neat, and it is. We've got enough clearance in there. Really, the last thing that I need to do is just place some mounting holes in there. And we can do that very easily as well. Our hole feature allows us to create any type of hole, whether it's a simple through hole, counterbore hole, countersink. Really, you can go through and change any of this to what you want it to be for any types of standards that your company might use. In this case, I'll place a hole here at the end of that radius. And then just for flexibility in mounting this, we'll go ahead and place several of these. Maybe we'll make a 7x1 pattern and we'll maybe equally space these by 20 millimeters. That way, as we mount the clamping mechanism, they can choose which mounting holes they want to use to mount that. Now, what is this part made out of? Sometimes you may want to get other information. How much does this part weigh? We have a built-in material table as well, and you can customize the materials that you utilize within your company. In this case, I'll make this out of aluminum cap. It has all of the different material characteristics here. I can just apply that to the model very easily. The other thing too is I want to make this look a little bit more realistic. I may want to show where these machining operations happen. So I may want to change the look maybe to some of these faces. We'll maybe change the colors of the slots. Maybe do the same thing here with the holes. Make this look a little bit more realistic. Do that. We'll go ahead and save what we've done so far. And then just one more drastic change. Maybe as I'm thinking about my design, maybe I realize that maybe to add a little bit more tension to this as it's mounted to the clamping arm, I may want to take this entire vertical leg, essentially, of my clamping arm, and maybe put a little bit of angle to it. So I can take that entire leg, maybe rotate that 5 degrees. That way when the clamping mechanism is attached here, add just that a little bit more tension to make the traction a little bit better for moving those heavy loads. So if we go back to the PowerPoint presentation, again, we saw that we were able to use the best of both worlds of both history-based modeling as well as direct modeling approach. Essentially, we use synchronous technology to very rapidly create a model with very minimal 2D drawing capabilities or 2D drawing elements. I was able to create that entire part by only drawing 2 single lines. The other thing we haven't talked too much about is the engine or the kernel which runs Solid Edge, and it's based off of a Parasolid kernel which Siemens owns. So it's the best in the industry. Many of our competitors utilize the Parasolid kernel on top of their CAD applications as well. So the next thing we want to do is we actually want to create a drawing of our model. We want to communicate that to the manufacturing floor. How does this part going to be created? How do we essentially make this part? So we want to document that within a 2D drawing. Right here from the model, I can very quickly tell Solid Edge to create a drawing of my model. Just come up here and say, let's create a drawing. And what it's going to do is it's going to place this drawing out onto a template. It allows me to very easily extract any views that I want. This is what we call a quick sheet template. Quick sheet template allows us to extract views and specific information from different views. In this top view here, I told it to extract any of the dimensions that I placed. If I want to add or replace any new dimensions, I have the same ability to do that here. Utilizing the same dimensioning tools that we utilize in the 3D modeling environment, we utilize the exact same tools here in the 2D drawing. So the users don't have to learn 2 different applications. They can utilize the same tools both in 3D as they do in 2D. So I'm just going to place a few dimensions on this view here just to show how that's done. We can also do the same thing in documenting the hole locations. Again, it's very easy to do that. Other types of details that you might need to add to the drawing, say for example, placing center lines and center marks, it's very easy to do that. Simply click on the geometry. Or if I want to do multiple center marks at the same time, I can window select, create all those simultaneously. Same thing with center line. Again, just place the elements there, just clicking on the hidden line. We'll do that for the whole locations up here as well. Creating other views is also very easy. If I wanted to create a detail view, I simply just create a circle. It'll automatically blow that up and create detail B. And then what's nice about that is as I move that detail circle around, it'll automatically update this so I can get this exactly where I want it and document exactly how much detail I want. The other thing, too, about the detail views, which is nice, is in this case, it's a 2-to-1 scale, but even when I place dimensions on this, it's going to place the dimensions per their true value. So it doesn't scale the dimensions up. It's always documenting what this is from the model itself. And maybe one more thing we'll do here is maybe I want to see some of the internals of this part, maybe here in this isometric view. We have a nice little tool here called Broken Out Section. That gives me the ability to come in and very easily create any type of shape that I want. Maybe I just want to create a broken out section down here. And how deep do I want that to go? Maybe I want it to go here to the middle of this, and I want to show that in this isometric view. So very easily I can create a lot of detail that I might want to see in my drawing. So again, in creating a drawing of your models, we're able to very quickly add views and clearly communicate our design. We can retrieve the dimensions right onto the drawing from the 3D model. It's very automated and allows you to adhere to national or even your corporate standards. The next thing I want to talk about is reusing data. And this data, as I mentioned earlier, could be 2D data. It could also be 3D data. Maybe your company previously had a 2D CAD system like AutoCAD, and you have a lot of legacy data. Maybe you want to reuse some of that data for newer designs. Or maybe your company has a different 3D CAD system that you're having issues with, and you're looking at switching to Solid Edge. Solid Edge has the capability to read in that data as well as reuse it, make changes to it, and really do whatever you need to do. When I go to the File Open menu for Solid Edge, you'll see down here in our list all of the different file types that Solid Edge can read in directly. So towards the top of the list are the native Solid Edge files. As you look down the list, you'll notice we can also open up many other CAD tools directly, both 2D and 3D as you see here. So we have AutoCAD, VWG, and VXF. Many of that information, much of that information is filled out there in that format. And then as well, if you get files from customers in a different format, or maybe you work with supplier or vendor data that's of a different format, or maybe you go to their website to download it, regardless of the format that you need to utilize, Solid Edge is able to open it up directly and do many things with it. In this example here, I'm going to go to AutoCAD. And again, just show you here, you can preview the document before you actually open it up. But there's a nice little wizard here. You know, we bring in the layer structure from AutoCAD directly. And then we can also do the same thing from a 3D perspective with those other tools. In this example, I'm just going to open up the AutoCAD file. And again, just show you how it opens it up, all the geometry and dimensions. It also brings that layer structure across. If I wanted to add some dimensions or add some geometry to this, I have all my drawing tools here. You know, what are my colors and what are my line widths? I can create additional 2D geometry relative to this. If I want to go through and place dimensions, I have all my dimensioning standards here, whether it's ANSI or ISO. If I want to go through and place dimensions on that geometry and drive that geometry parametrically, I can do that here in 2D, just like I did in the 3D environment. So it gives you the ability to very easily drive geometry and make it parametric just like you did in the 3D world. The other thing, too, is I can actually utilize the existing elements off this drawing to create a 3D model very quickly. We have a tool here called Create 3D. Essentially allows us to take the 2D information off of a drawing and create a 3D model very easily. So for example, I'll take the front view as well as the side view. This is just a sheet metal bracket that I want to reuse. And I actually clicked a little bit too quick there. Let me go back to that for a second. So again, you'll notice that I'm picking not only the 2D geometry, but I'm also picking the dimensional information off of these views. So what it does is when I click on that information, it takes that information into a modeling environment for me. And you'll notice it lines up the side view relative to the front view. Again, takes all that dimensional information And very quickly I can come through and start creating 3D model from this. We'll grab some of the elements off of the front view, extract that out to the front, and round some of these front edges here. And for that mounting hole there, let's just quickly add a hole. And just in a matter of seconds, we've constructed a 3D model from that 2D drawing. Okay, that was probably less than a minute there. Now, again, if you're used to using a history-based system where you're creating sketches, and from that sketch you're creating a 3D model, you know that those two things are tied together. If you change anything on the sketch, it automatically updates the 3D model. But what I want to show you here is I'm actually going to take the 2D sketches that I brought in from AutoCAD. I'm just going to delete them out of the file. Don't need them anymore. Because once I have the 3D model, everything is now driven directly on the 3D model. So for example, all of the manufacturing information that was on the original AutoCAD file, I can now utilize that and drive a model parametrically. So for example, maybe I want to change this height of this little clamp here. Notice I can click on the dimension directly now and modify that. Or maybe I want to change the angle from some other value. So very quickly, not only can you create a 3D model, but it's also highly editable. The other thing I want to draw your attention to is when I constructed the model, I was utilizing what we call a part template. Part templates are typically more for plastic or machining or machine type components, but this is actually a sheet metal part. And what's nice about Solid Edge is I can take any type of component like this and convert it into a sheet metal part very, very quickly. So we have a nice tool here called Thin Parts Sheet Metal. Just simply click on the part, and now it can act as though a sheet metal part would act. So I can create flat patterns and things of that nature for manufacturing purposes. If I want to change bend radius or bend angles, things of that nature, now I can click on that bend and say, well, let's go from 3 millimeters to 6 millimeters. I can also come in and say, let's create a flat pattern for manufacturing purposes. And it'll flatten that out for me. It gives me what my sheet size needs to be in order to manufacture this part. So again, just a matter of a minute or two, going from a static 2D drawing to a very dynamic 3D part model that I can now reuse. Let's save this. We'll go back and reuse the part numbering system. And we'll just call this bracket. And we can go ahead and close this file. We'll bring this bracket into to our assembly that we were working with earlier. So let's go back into that assembly. We'll close out of this particular part now that we're done with it. Come back to the assembly that it's in. We're going to place that sheet metal part here and connect it to some of our other components. Bringing parts in is very easy to do. So for example, here's that sheet metal part we just created. Go ahead and just simply assemble it where it needs to go. Again, we're just clicking on geometry. Move that around, and we'll line this up relative to these other components. Now, sometimes when you're reusing data, maybe you didn't check carefully, or in my case, I didn't check very carefully. We were able to use this as kind of a starting point, but as you'll notice, this part doesn't quite fit like we want it to. It's close to what we want it to be, but not quite exactly. So I need to make some changes to this. So obviously we have a difference in angle here. How do I fix that with Solid Edge? Well, let's first find out what that difference is. And it tells us that the difference is it's a 10-degree angle difference and mounting it to the location where it needs to be. So what I want to show you is I'm going to isolate this part by itself for a second. And in Solid Edge, what's nice about this is I can take that angle, I'll show the rest of the components. I want to take that angle and just change the angle. So I can drag that up, I can change it, don't want to bend it quite that far, but again, just type in that value, in this case 10 degrees, and get that mated up to the component exactly where it needs to be. Some other differences here in reusing this data is my slots where my molded components need to be are not quite where they need to be. Again, with Solid Edge synchronous technology, changing the location of these cutouts is very, very easy to do. I can just simply tag it to the center point of that bolt and move that slot location where it needs to be. Anything up here, maybe I want to push or make this entire section of this part a little bit shorter. So I can just window select around all that geometry, and again, just very quickly make this change. We'll drag this down to where it needs to be also. So very quickly, I've created the 3D model from the 2D drawing. I've repurposed the geometry for what I need it to be, and I've done that all within a matter of a couple minutes. And we use that. So again, we went from legacy 2D data, converted it to facilitate reuse. We did that and made changes very easily to it. Saved us a lot of time and a lot of effort. And again, if I wanted to do this with other 3D data that may have came from other 3D CAD systems, I can do exactly the same thing that you saw there. Let's do a little bit of assembly work. Let's put some pieces together. We'll talk about standard components, nuts and bolts, things of that nature, and what comes with Solid Edge there as well. So let's come back out to our top level assembly. And let's show some other components here that we want to work with. And let's go back to that clamping mechanism that we looked at earlier. Let's actually get that assembled where we want it to go. So again, I very easily just select geometry and move those parts where they need to go. Very easy to do that. Get that into position. And then obviously to lock this in place, we probably want to put maybe some screws or some nuts in there and just kind of keep that in place. And Solid Edge has a nice tool called standard fasteners. Allows me to create these very, very easily. And I don't want to put fasteners in all of the holes, just in the ones that are going to mount this onto the clamp arm that we created. So I'm just going to select the top hole and the third hole here. And by selecting the depth of the hole, Solid Edge is going to intelligently go out to our machinery library and pick the components that would fit into that side hole. So as it works its way through the library, it's kind of filtering out which components are going to be available to place inside of that hole. So over here on the left, I can select, do I want to put a bolt or a screw? Maybe in this case, I want to find maybe a hexagon socket head cap screw. So I'll go to that, pick my standard, and then it'll tell me which ones are available. Maybe I want to put an M10, so I'll just add that to the list. That's in my bolted components. And then maybe for other components, I just come out and select specifically what I want. Maybe we'll put in a prevailing torque type nut, and then it gives us a nice freebie there. We'll add that to our list. Now I'll show you here, as soon as I click OK, it'll populate those two holes. Now this is a feature, so if I decided later on I wanted to change which holes those were located in, I can come back at any step in that process and change that. It's very, very easy to do, very flexible. The other thing too is I might want to make the look of my components look a little bit more like the other hardware. So we have a nice design palette here. Allows us to pick from a different list of material finishes. I'm just going to take the chrome finish and place it out here on the bolt. And change the look there. We'll do the same thing from the style palette. We'll place that onto the two nuts. Change that very, very easily. It's simply just a drag and drop. If your company wants to create more photorealistic renderings and make the parts look as though it was taken with a photograph, make it look very, very realistic. Solid Edge also has a tool called KeyShot, and it does photorealistic rendering on your designs as well. The other thing we'll talk about in terms of assembly is let's come in and let's maybe add some additional components. Let's let's go into kind of where the caster wheel is here on the back. I want to show you here, we only have the one caster wheel in, and we want to place an identical set on the other side. And obviously we can go to our libraries and drag those in, but what I want to do is just show you how easy it is to copy from one location to another. So again, I'm just going to window select around the existing caster. Place that relative to the center point there. And just like if you were in Word or PowerPoint, if you hold down the Control key, it'll copy text. I can do the same thing here with components. We just want to copy that to that new location. Very quickly, I've replicated those parts. And not only did it copy those parts, but it also assembled them at the same time. So mating conditions, things of that nature. If I needed to align holes, it automatically placed in those assembly relationships as I copy them over. Very, very intelligent tools in terms of assembly design. To save what we've done up to this point. I've got a couple more things we need to do to complete our design. But as you saw here in the assembly design process, again, a lot of these tools are automated. We needed to go through and check fit and function, and rapid component duplication, again, is going to increase your productivity. Let's go ahead and document our assembly as well. We'll come back to the drawing that we created earlier. Actually, let me go ahead and save that initially. Save this folder for the first sheet. If I want to add multiple sheets to my drawing, I can do that very easily as well. And let's go through and document the assembly that we just worked with. We'll come out here to our drawing view wizard. And again, maybe if I don't remember exactly where those components are located, Solid Edge also has a nice search tool. So if I want to come in here and search based off of keywords or specific files, I have a nice search tool here. I'm just going to do a keyword of hook. Maybe I have that name in the clamping mechanism. And as I search for that, Solid Edge very, very quickly will go through and find where that file resides and allows me to place the different views of that clamping mechanism on my drawing. In my case, I'll actually want to go through and do a nice exploded view. And instead of the typical black and white view, I actually want to render this view so we can see the components a little bit easier. So again, very, very easily I can take assembled components, explode them, and place that view onto my drawing. And then if I want to document this inside of a bill of materials or a parts list, I simply just click on the view, and I can choose from any company standard, and it not only balloons all of those components, but also generates a nice parts list. Now in the parts list, it works very much like Excel. So for example, if I actually want to spell out or make modifications, maybe a title, for example, I just simply click in there. The other thing that's nice too is if I want to see which components I'm referring to from the list, I can just put my cursor here and it gives me a nice thumbnail of which part it's referring to. If I actually click on a cell, it'll actually highlight where that part is inside of the drawing view. So very easily, I know exactly what parts my list is referring to relative to the drawing view. So again, very easy to document your assemblies, just like what we saw with the part components. Talk a little bit about testing our components. We come back out to the assembly. I may need to test this part and make sure it's going to work under the conditions that we're in. So let's go back to that sub-assembly. We'll open that up. Again, Solid Edge has built-in simulation tools, both for single part as well as assembly. I simply just say I want to create a new study. And the Solid Edge has linear static studies, normal modes, linear buffering, and then we also have some steady state heat transfer options as well. In this case, we'll do a linear static. And very easily, what I'm going to do is just apply the loads that we need to our component. So in this case, we will maybe place a force as this part's pulling a heavy load. Maybe there's going to be some force on those bolt locations. And then which direction is that force going to be? And then how large is that force? In this case, maybe 250 newtons. And then we will fix it relative to of this cylinder here. And again, once I've done that, it gives me the ability to solve this, exactly what's going to happen under those conditions. So as we look here, I can turn on the remaining components. I can animate. Obviously, the animation is a little exaggerated just so you can see what's happening. But as we apply the loads, we can see, where we may have high stresses. If we're looking for factor of safety as an example, we could look at that. Let's look at factor of safety in this case. So maybe we want to, for example, have a factor of safety between 2 and 3. So let's go ahead and display that. So 3 is in our case good. 2, not so good. We actually want it to be closer to 3. And if we look at the display of our model, you can see we've got a little bit of issues here where the radius is. We might want to make some design changes to accommodate for that. So I may need to make some changes to this. So let's go through and make some modifications. Maybe we want to thicken up the clamp arm. If we do that, we may also need to make a change to this sheet metal bracket. But Solid Edge, I can do that all in one shot. I can make changes to several components at the same time. So in Solid Edge, I just simply click on the geometry that I want to make modifications to. I'll grab the face of that sheet metal bracket, and I'll start to make this change. Now, the dialog box that you see here is part of our built-in data management. Now, as I try to make a change to that sheet metal part, Solid Edge automatically tells me that, hey, this part has been released. You can't make a change to this part because it's been flagged as released and it's read-only now. So as the designer, I know that I need to either create a copy of that part and make a change, or maybe I need to revise that part. So if we look over here on the left-hand side for that sheet metal part, it's telling me that I'm utilizing revision D. And you see it also has a red check mark. That's a visual indicator that this part has been released, which I didn't see initially. What's nice about this is in Solid Edge, all I simply have to do is look at that first, tag that part, come here and say I want to revise this part. Solid Edge will go through and automatically create revision C for me. As soon as I save that, it automatically replaces revision B with revision C, and now I can make the appropriate changes that I need to make. So let's go back and do what we were trying to do earlier. Let's make changes both to our clamping arm as well as the sheet metal bracket. We'll do this all at the same time. And we'll maybe extend that face up, change that, let's say maybe 5 more millimeters. And we also had some issues in the corner, so let's go through and maybe make a change quickly to the radius here. I don't want to change all the radiuses. I just want to change that single radius there in the center. And maybe we'll change that to, let's say, 5 millimeters. Make that a little bit bigger. Once I've made those changes, I can, without doing anything else, I can now resolve the analysis. And let's get the feedback that we need to see based off of the design changes that we made. And again, just a matter of seconds, we can see that our stresses have decreased. And if we want to look at, for example, factor of safety, we can do that as well. See exactly where we are in that range of 2 to 3. And now you can see we don't have any more red or low points of factor of safety here. Those design changes did exactly what we needed it to do. I know we're getting short on time here. I don't want to go into a ton of detail here in simulation, but we also have automatic report generation here, where you can create a report very, very quickly right here from the simulation environment and get all the information to pass along to whoever you need to send the results to. Now, we made some changes to our clamping arm here. If we were to go back to our drawing, just wanted to show you how Solid Edge is constantly keeping track. So if I need to update my drawing views here, what's nice about this is Solid Edge gives us instantaneous feedback. It tells me whenever I go back to the drawing and update it that, hey, some values have changed here. The value used to be 37, now it's 42. This radius used to be 2, and now it's 5. So what's nice about this is I can copy those content here, and then if I needed to document, any of the revision changes that have happened, if this were a revision, I can come in and document that here. We'll paste that information, and now I've got references to the changes that have happened or maybe revisions, and I can go in there and modify that text whatever I want it to look like, but giving that feedback is really nice within Solid Edge. So we saw how we could, again, test our components very easily utilizing Solid Edge simulation. That's going to reduce physical prototypes, material costs, and things of that nature. And then finally, to wrap up, I want to show you a little bit of the design management tools that are built into Solid Edge, show you how you can navigate the data simply, quickly find the files that you need, and also collaborate with team members or customers. Actually, I'm going to go into Windows Explorer. Many customers today are managing their documents just with basic Windows functionality. And you can see here we're also utilizing our Windows Explorer, but with Solid Edge, with the built-in data management application, we can very quickly find files because we utilize an indexing approach. So for example, if I want to find any file that has the title of pump, you'll notice that very, very quickly, within a matter of just a second or so, it finds anything that has pump in the title. If I click on that file, it will show me a nice preview of it, and then we'll find that. If I come in here and type in the name master, we want to find the top level assembly, we can find that as well very, very easily. Now, I'm going to send this document here that we've been working with to our design manager. I'll show you some additional information you can get out of the design manager and how you can see which components are there and get other information. So within our design manager, again, we pulled up the master mover. It gives us information here, what manufacturing information is. This is an assembled component. Gives us information such as the title, the document number, what revision it is. It also tells us the status of the component. So you can see many of these files are available to work on. Some of them are actually in work right now by somebody else. And then you can change these statuses based on where that is within the process. There are some other documents here. Remember the clamping mechanism we looked at. If I want to see a preview of that, here I get a nice preview of the document. I can get information relative to that as well. Maybe I want to open up one of these within their own window. I can do that also. But the nice thing about this is our design manager allows us to collaborate with others within our organization, or if we needed to send this off-site to somebody else, I can take all of this information very easily and move it. Solid Edge recently became cloud-enabled, so we can also utilize cloud services such as Dropbox or OneDrive to very, very quickly take documents and share them with others utilizing those services. So for example, if I came in here, if I wanted to take this entire assembly and move it to the cloud, move it maybe through Dropbox, as I mentioned, or OneDrive, I can come in here very, very easily and select a different location. If I have a site set up or a Dropbox location, I can select my Dropbox location, specify what folder I want it to be in, and if that is replicated on the other end, these documents are going to go through the cloud and allow us to share this information with our other team members or maybe with a customer. So it's very nice to have all this information built into the CAD tool. You don't have to have a formal document management system. It allows you to do this right here within the CAD system itself. I'm going to go ahead and turn this back over to Rich if we have any Q&A. Again, I appreciate everybody's time here. I know we have maybe 5 minutes or so for question and answer. But if we want to open it up, Rich, I'll turn it back over to you.
Thank you, Kevin. Great presentation. Hopefully everybody enjoyed the presentation from Kevin, and I think it was a great overview of the product. At this point, we'd like to just open it up to question and answer. If there's any questions from the audience, feel free to unmute your phone and go ahead and ask your question. In the meantime, I did get a few questions that came through the chat line, so I'll go through those unless someone speaks up. One of the questions I have here is, we don't do enough design to justify purchasing Solid Edge. So, Kevin, if you want to go ahead and maybe answer that one.
I guess I need to know a little bit more information. I think, there are many examples of Solid Edge customers that aren't able to cut the time to design the product, not just ease of use, but I guess trying to understand the justification. I don't know if you can expand on that or not, but we'd be happy to show you how easy Solid Edge is to use with the different tools that you use on a day-to-day basis and what your workflows are. Maybe you can send Rich an email or set up a phone call, and maybe we can dig a little bit deeper into helping you make that justification.
Yeah, we would certainly welcome having an offline conversation to take that discussion further. So, okay, another question that I had is, Solid Edge appears to be a little bit more than what this particular customer needs, and they really don't see a need for 3D at this point. So, maybe expand on that a little bit, Kevin, and what your thoughts are on the advantages of 3D, I guess, overall.
Yeah, I think the one that probably comes to mind is just the visualization. Sometimes when you're working just with single components, the visualization of a 2D drawing isn't that bad. But sometimes when you're looking at maybe a layout or an assembly of 2D only, a lot of times it's hard to visualize what am I looking at. It's hard to detect interferences and things of that nature. So 3D is obviously a lot better from the visualization standpoint, being able to check for fits or interferences. The other thing is, I'm seeing a lot more customers today that are requiring 3D documents in terms of being able to work with that, a customer. So 3D is trending upward in terms of the need. The other thing that I see is it correlates to some of the trends in manufacturing and being able to go directly from a 3D design model into some of the 3D printing capabilities. So many of the manufacturing systems out there, whether it's 3D printing or some of the traditional manufacturing processes, a lot of times they can take that 3D model directly for the manufacturing process. But yeah, again, there's probably other reasons or other examples, but visualization, just in communicating with customers or maybe during the sales process, being able to really see a design in 3D, communicate that a lot easier than in 2D. But then again, some of the downstream applications of manufacturing and other things, I think, lend itself well to having a 3D system.
Yeah, and just to add to that, 3D is basically here to stay. I mean, it seems to be the trend of the way the industry is going, and it certainly can help you overall in your design process. So one last question that I did have here is, we already use SolidWorks, why change? I'll go ahead and answer this, and then Kevin, if you want to add to it after. Basically, what we have seen from customers is, the overall reduction in the design cycle for most customers is anywhere from like 20 to 30%. And there's a lot of benefits in reducing costs and man hours required by using Solid Edge versus SolidWorks. It saves time, and certainly we can take this discussion offline and give you further justification on why. Anything you want to add there, Kevin?
Yeah, in terms of maybe the data that you created with SolidWorks, we didn't show this today. We could come back and show this as a follow-up, but Solid Edge reads in SolidWorks data directly. We also have a data migration tool for SolidWorks that's built into Solid Edge, where if you wanted to migrate, a bulk load of files all at the same time, not only do we read the data in, but the data can be, we talk about materials and file properties. It's not just about the geometry, but it's about all this other information. My materials, my file properties, I have configurations, all of this stuff that I've created in SolidWorks today. Solid Edge reads in all that information, and we have the ability, if you need to work with the geometry and make geometrical changes to it, Solid Edge does that very, very well. So the transition from SolidWorks into Solid Edge is very easy, it's very seamless, and you can continue to work with that original data.
Great. Okay. Any last questions from the audience before we wrap up here? Because it is just a few minutes after 12 now, so let's go ahead and close out the call. And thank you, everyone, for joining us this morning. We certainly appreciate your time. And if you have any additional questions, we would be happy to schedule some subsequent follow-up calls. We will also have a copy of this recording published in the next few days, and we'll be sending that out. It'll also be on the PROLIM website. So thank you again. Kevin, appreciate your time, and everyone have a wonderful day.
PROLIM